What I want to talk about today was twofold. First thing we want to chat about a little bit is why live forensics? Why are we doing live response? And the second thing I want to talk about is a tool that we've released at DFLabs, the company I currently work for now, that will help you kind of script and automate some of your live response collection. I really appreciate the two keynotes because they teed things up for me very well, talking about kind of the crossover between incident response and threat hunting, as well as what is evil, right? We talked about this morning. How do you find evil? What is evil? What needs to be looked into versus what may be normal. So why do we do live forensics, right? Well, as he talked about in the introduction, dead box forensics, we just really don't do it anymore. There's no time for it. The amount of data that we're collecting in those kind of situations is just kind of, unnecessary. So we do live forensics when we want to preserve things like running processes, network connections, open files, things like that. When, we know those are going to be lost, even if we did pull the drive or shut the system down, right? And obviously, there's situations where a system can't be shut down, so we have to do live forensics, right? Try telling somebody that you're going to shut down their domain controller, or you need to take critical application offline because you think it may be compromised. So we're forced to do live forensics at that point. Now, of course, there's, we've heard other talks about some great EDR tools, some great network collection tools, things like that, that are great for grabbing things like running processes and network connections. So, why do we even need to do live forensics? Well, sure. Some environments may not have those EDR tools in place. Obviously, in the smaller environments, it may not be affordable. And there's still going to be times where, as great as those EDR solutions are, you're going to need some more in-depth information, right? You're looking for hooks or, evidence of advanced threats. Those may be things that your EDR tools aren't going to pick up. So, as Ben talked about, right, threat hunting versus IR. We've heard a bunch of different people mention, what is the definition? Where do those two things intersect? And I think we can all agree that there's a lot of crossover. We may not agree on exactly where that is, what the definition of one versus the other is, but there's a lot of crossover. So your IR obviously starts with a pivot point, right? When you're doing an IR investigation and you're going to do live forensics as part of that, you've got that pivot point. Maybe it's an AV alert. Maybe you've been, something alerted on a data breach. Maybe you've got a IDS alert, right? You've got that pivot point to work off of, and you can work from there. In threat hunting, we're looking for that pivot point, right? So we don't know that there's an alert. We don't know that there's an incident. We're looking for that sign of something that's abnormal so that we can go from there, and then the IR starts. So there's a lot of crossover between the two. Now this morning, another great tee up, we talked about what are signs of evil. What are we looking for when we're doing these live forensics, right? Well, we're looking for things that I shouldn't say are always bad or bad no matter what, but are more normally suspicious, right? Things like your misnamed processes, connections to known bad hosts, right? You've got something connecting to something that's, on your threat intelligence list. That's probably bad. Abnormal process owners, right? I think we all got a copy of the Find Evil poster. Everybody knows that. Everybody should be using that. That's a fantastic resource. So I don't need to go up here and regurgitate all that to you, but that's what you're looking for. Now, some things are going to be more subtle, right? Those sort of things that Rick talked about this morning. Maybe they're normal, maybe they're not normal. Maybe there's a good reason for this happening, but it could be completely malicious or completely benign. So, odd ports, code injection, things like that. That may be normal for your AV, but it's probably not normal for, Adobe, right? Hopefully. And like they talked about this morning too, establish your baselines, know what's normal. If you're going to be doing good quality threat hunting and you're going to be doing live forensics and acquiring this data off of these hosts, right? That's what we're going to talk about, is how to actually acquire that data to examine. You need to know what's normal. You need to be able to compare that to something, so baselines are hugely critical. So when we talk about doing live forensics, right, it's a great tool. We all know there's a dozen reasons why we should be doing it. But there's certain challenges that you run into in live forensics that obviously you don't run into with the traditional disk-based forensics, right? It's very, very important that that process be documented, because when you're doing live forensics, you're changing something, right? I mean, there's no way around that. You are altering the data, and that used to be 10 years ago. That was a no-no. You know, we can never change the data, or we can never use it. And that's just not the case anymore, but it's important to document that because you need to be able to prove how you change the evidence. Are these artifacts on this host a result of something I did, or is it a result of something the attacker did? And if your process isn't documented, if you just have this ad hoc process where you're going to plug in a drive, go run some tools, and get the output, and then 6 months later, you go to court or there's some sort of a legal proceeding and somebody asks you, well, what did you do? You know, I plugged something in, I ran some tools, and this is what I got. Well, okay, you know, you're going to have a bad time. It needs to be something that's repeatable. That goes to the same point. You need to be able to say that, look, this is a process that we've tested, it's documented, and we do this the same way every single time, right? That's hugely important. And it needs to be secure. You're running something on a live system that may be your domain controller, it may just be a user workstation, but it could also be a critical application system. So it needs to be something that's secure. You need to know what you're running, and you need to make sure that those tools that you're running only do what you expect them to do, right? I mean, hopefully, you know, worst case scenario, it just does something unexpected. Worst case scenario, right? Somehow your USB drive or whatever you're running the tools off of got infected with malware, okay? And now you're installing a rootkit on your domain controller, and you're going to have a bad week. So it needs to be a secure process. So how do we achieve that? Normally, it's through batch files, right? Normally, you know, we've got 2-3 dozen different little individual live response tools. Maybe one goes out and grabs network connections, one's going to grab, you know, open files, things like that. We get all these little tools that are great at doing the individual thing that they do, and we put them all on a USB drive, and then we script them via a batch file because we want it to be a repeatable process. We want to be able to take that batch file and say, this is exactly what we ran. Okay, well, that works, but there's some problems with batch files when you start looking at some of those requirements, like being documented and secure. There's no native logging or audit trails in a batch file, right? You run a batch file, it runs, that's it. That's all you get. So if you want to have that documentation, that's something you have to build into your batch file. Now I've got to not only run put commands in my batch file to run the tools, I've got to put commands in there to pipe the output out. Now I need to put extra commands in there to actually, you know, make sure that I'm documenting what processes were run. Some tools are OS or CPU architecture specific, right? So maybe I have a great tool that I love, but it only runs on, you know, Windows 7 or newer, or maybe it's only for 64-bit systems. Okay, now I've got to put those statements in my batch file. It's easy to modify batch files, right? Again, you talk about the best worst case scenario and the worst case scenario. Best worst, you know, maybe somebody just opened up the batch file, accidentally edited it, and made some changes, and now something's going to fail to run. Worst case, somebody does something malicious, and now you're running commands through your batch file that you don't mean to. And like we talked about earlier, tools can easily be deleted or replaced, so it's not terribly secure. When I was doing IR, the last batch file that I was using to run all of my tools, I think was something like 1,700 lines or something stupid like that. Now granted, that had some, you know, pretty output and do you want to do this and that sort of thing. But, you know, then you go try to add another tool to that, and you've got to parse through 1,700 lines to figure out exactly where you want it. And so there's some issues with batch files. So what I started writing and finally finished when I took this new position was something we're calling the no-script automation tool. And the idea is it's free, you can download it. It's supposed to kind of help overcome some of those limitations of batch files, right? So obviously, right, no scripting required. That should be kind of obvious from the name. What we wanted to do was make it easy to configure for different CPU architectures, different OSs. Wanted to take care of those things that you normally have to spend all kinds of time scripting, like logging and hashing output. And we wanted to take care of some of the security issues of batch files. So making sure that the commands and the tools are verified before you run them, they're known and they're documented so that you can go back to that afterwards. So as a teaser to the end, I didn't put the link to actually download it until the end, so everybody has to stick around. So we're going to jump right into actually configuring it, and then I'll tell you at the end how to download it. So the idea behind NAT is that you have this one executable that will basically automatically take care of executing all of those tools that you would normally have to put in a batch file. And so the way we do that, and we'll see, in lieu of being the only person out there who had to have like a laptop to do a live demo, I put some videos in here. So there'll be a couple videos actually going over this process and executing the tool. Hopefully I can talk at the same speed as the video. It's gonna be a little bit awkward, but we'll try it. So to configure it, to set up your tools, you just create a tools directory, right? So you've got your USB drive, you've got NAT sitting on your USB drive, you create this tools directory, and then you start to organize your tools into different categories. Now you don't have to, you can just throw them all in the tools directory and run them all at once. But the nice thing about organizing them into this tools directory that's over here is that you can create an INI file, or one or more INI files, that will allow you to specify which directories you want to run, right? So there's a default .ini file. You're going to set it up to run everything. But if you only want to run maybe your file system and your OS tools, you can have an INI file that just specifies those two directories, call that from the command line, and run it that way. So it's a good idea to be able to split up your tools like that. So the other thing you can do within these tools directories is set up individual folders. So we can set up folders here for operating system version numbers, as well as CPU architectures, and nest them inside. So you can have your file system directory, and then you can create a 6 to 10.0 folder. So when you're running tools from the file system directory, it's only going to run on Windows versions 6 to 10. You can create an x64 directory that will only run tools on a 64-bit system. And that will take care of all this automatically when it executes. It will automatically detect the OS and the CPU architecture and just run the proper tools, so you don't have to script all that stuff. As you can see, you can nest them here, so you can have a 6 to 10 and then an x64. You can do it in reverse, but you can't double down on that. So you can't have a 6 to 10 x64 and then an 8 to 10. It only goes 2 levels. So how do we specify command line arguments, right? That's important. We don't just run tools. We normally run them via the command line. We're going to put them in to a text file that's just named with .cmd at the end. So if you want to run ping.exe, you just create a new text file, put it in that same directory with ping.exe, and call it ping.exe.cmd. And you just put the command line arguments right in that text file. Now you can have more than one. So if you want to run the same tool with 3 different command line arguments, you can certainly do that. You just put one on each line. It will execute it once per command line. All right, so this is the first video. Okay, so we're going to create that tools directory, and that's going to be where we're going to store all of our tools by default. Now, it's going to be in the same directory as the NAT executable itself, because that's where NAT's going to look for it. So within the tools directory I talked about, we're going to create those individual sort of category folders, right? So we'll create a folder for our network tools, our OS tools, things like that. So we'll make our network directory, and within that, we can start adding our different network tools. So in this case, I'm just throwing one tool in here for a demo purpose. Now you'll see, when I run this, I tend to prepend everything with a name. In this case, I've used nat underscore. It's not a requirement for the nat tool, but it is good best practice. Again, we talked about differentiating what you did versus what maybe an attacker or somebody else did. So the easiest way, or one of the easiest ways to do that, is just prepend a file name in front of all of your tools, so you can see, hey, you know, that was obviously associated with something I did. Now you can see here, I'm going to create that x64 folder, so we can jump inside that. and put a tool inside that will only be run inside of a 64-bit OS. We can also create that file system, the operating system version folders. So we'll create that 6 to 10 folder there, and that will only be run on Windows Vista through Windows 10 operating systems. And then within that, obviously, we can nest another directory there as well. So we threw that 6 to 10 directory inside the 64-bit folder. So now it will only run on 64-bit operating systems. Okay, so now I'm going to throw that .cmd file in there, and we'll open that up, and we'll take a look at it. You can see it's named the exact same as the executable. That's how NAT ties those two together. We just append a .cmd at the end. And you can see in this case, all I'm doing is just accepting the EULA, right? It's one of those sysinternals tools that's going to pop up a EULA, so we can make sure that we accept the EULA and we don't get a pop-up when we execute that. But you can put any commands you want in that .cmd file. So there's a couple of special commands that you can put inside the .cmd file that are specific to NAT. They're variables that allow you to do some special things, and NAT will replace these variables when you actually run the tool at runtime. So the first one is the no out variable. And basically what that's going to do is tell NAT that it doesn't need to take care of the output. Right? So some tools, you can do a -o and specify the output directory. You don't need NAT to pipe that output for you into a file. So if you specify the no out command on in the command file, NAT will not pipe that output out for you automatically. You can specify that in the command file. Now obviously, where we do that is going to be different for each execution, right? You don't know what drive letter, what folder you're going to want to pipe the output into when you're running NAT at runtime. So that's what that second variable is for, the outdir directory. When you run NAT, it's going to ask you where you want to output the files to, and that's going to change. So you can use that outdir variable within your command file to specify whatever output directory is chosen at runtime. And the last one is just the sysroot variable, right? See Windows System 32. But on some systems that can change, so that's just a variable that you can use. So how do we actually run this? What does it actually look like when we execute? So this is the command line interface. Pretty simple. You've got a help menu, obviously. We'll talk about integrity files. We also have that INI file. So like I said, you can create the default INI file. That's what will be used if you don't specify anything. But you can specify that INI file on the command line if you want to call a different one that maybe only runs a certain subset of your tools. While we're waiting for me in the video here, the integrity check file is something that can be used to verify the tools that you're running, right? So we talked about tools getting accidentally replaced, maliciously replaced. We talked about the same thing in your commands. So an integrity check file basically allows you to to kind of create a gold standard, if you will, or a known set of tools. You create that, and then you can create this integrity check file, and every time you execute NAT after that, it's going to check and make sure that all of your tools are the way they were when you created that integrity file, right? So nothing's been changed, no MD5s are different, no command line arguments are different. So we'll go ahead and we're going to run NAT. And you can see you get a security warning. We haven't created that integrity check file yet. So it's going to pop up and say, hey, you know, you're not verifying your tools. This can be dangerous. Are you sure you want to continue? Now, there's nothing that you can if you want. You know, I'm not here to tell you how to do your business. It will at least prompt you to say, hey, something, you know, you should be creating this integrity check file. So we're going to select no. And then we're going to run NAT, and we're going to run it with the /c command to create that integrity check file. And you can see what it's done is it's gone through and it's hashed every single executable in all of our paths. It's hashed all of the .cmd files. And you can see for the text files, it's actually also displaying the content of those text files. So it's actually going to show us what commands we're running. So it's going to go through, it's going to do all that, it's going to display it to you, and we're going to say, are these commands and executables trusted? If you say yes, it'll create that integrity check file. And you can see it's going to ask you for a password. So we enter the password, and it's going to take that information and encrypt it and put it into a file on the USB drive itself. So that will always be present there. And it will always check that from now on every time you execute NAT. I should have done this in like 6 or 7 chunks. I apologize. All right, so now we're going to go ahead and run NAT again. Now you can see it's going to prompt us for the password. So we'll go ahead and if we enter an incorrect password, it's going to pop up, tell us the password's wrong. If we run it again, this time we'll enter the correct password. Possibly. Might enter the correct password. There we go. Okay, so you can see what I've done here is I've I've modified that respond.bat file. So this is what happens. We enter the correct password. It's going to pop up and say, hey, something doesn't match here. Now, do you want to run this? Are you okay with this not matching? Is this an acceptable change? Or is this maybe malicious? We can see in this case, it's going to show us what the new file was. If we want, we can use V, and it will actually display the contents of the integrity check file that currently exists. So we can compare what it used to say with what it does say. Now, in this case, I just changed the text to, this is another sample batch file versus this is a sample batch file. And we can choose then after we view the contents of that, whether that's an acceptable change or not. Now, there's some, in the security warning, you'll see it notes, some tools do change things like config files every time they execute. So it's not always malicious when you see a change, but it's something you want to look at. And so that's why we can display both versions and give you the option to run that tool or not. So you can see we've entered the correct password, no change has been made. We can see it's detected as 64-bit Windows 10 operating system. And it tells us by default the data is going to be written to the D drive in that particular folder. Now, the way that that's chosen by default is the root of the drive that you're running the tool from and the name of the Windows host. So you can change that if you want, but that's the way that the default is chosen. If you're running it from, say, a Windows share or something like that, obviously you can change it, but in this case, we're going to say no, we don't want to change it. That's going to go right into the execution, and we can see it's going to tell us as we're executing what tools we're executing. It's going to hash the output at the very end, and then it's going to tell us whether it completed successfully or not. And that's how simple it is. There was no other scripting required. It's just going to run all those tools for us. So as soon as I click any key to continue here, we're going to jump and just look at the output real quick so we can see what we're actually collecting. So we can see this is the directory that we've created up here. Now, if we open that up, we're going to see there's a couple special files in there. One of them is the nat.log, which is our log file. The other one is md5.txt. And then you can see we've got the same directories that we saw in our INI file. In this case, I only ran it with 3. So the nat.log file, which I believe is the first one we're going to look at here, that's going to be a log of all of the activity that Nat took. So here we go. So we can see it's time-stamped. We can see exactly what commands were executed, what tools they were run from, what the MD5 hash values of the tool, all that stuff is. So when we talk about the process needing to be documented and repeatable, here we can see we can document exactly the date and time we ran the tool, what the hash value was, where it was located. Everything is right there, and that comes prepackaged right along with all of your output. Dramatic pause for the next file. This is the md5.txt file, and this is a hash of all of your output. So the very last thing we do before we exit NAT is hash all that output. So as soon as those were created, we have a hash value of the output of each one of the tools you ran. So you can prove that, right after I ran it, this was the hash value. This hasn't been modified. These are our legitimate files. And the very last thing we'll look at is just some of the sample output. So you can see we've jumped into the network folder. We can see the output is going to be named for the tool. So tcbvcon.txt, I think, is the one I opened. That was the tool we ran. You can see we've got open ports and then open ports _1. That's what it'll look like if you run a tool with more than one command line option. You'll have a 1, a 2, a 3 appended to it. So you've got the output in separate files. So if we open tcbvcon.txt, we'll see it's basically just going to be the output of the text of the tool that we ran. But the only thing that will be appended up at the top is going to be the date and time that it was executed, as well as the command line arguments that were executed. So if you're running the tool multiple times, multiple command line arguments, it will tell you what command line you executed that tool with. So final notes on the tool before I wrap up. Free. Use it at your own risk. If you blow up your domain controller with it, don't send me hate mail on Twitter or something. Just do your thing. It's available at dflabs.com/nat. It's a marketing thing. I tried to get it without the, put in your name and your email address and all that. They do ask for that information before you download it. We won't spam you or anything like that. Give you a little tip. All that's going to do once you register is send you to our GitHub page. So if you came across our GitHub page, you could probably download it right from there without having to put in your information. Just throwing that out there. Questions, comments, suggestions, any other entertaining things that you want to send me, that's my email address right there. If you don't write that down, you want to contact me later. I'm LinkedIn, Twitter, and obviously you can contact me right through the company on our website. All right. Well, thank you guys very much. It's a download link. Appreciate the time.